Alright, so we're going to look at solving derivative functions. These are really important for identifying how things are changing. When solving derivative functions, which remember are instantaneous rates of change, not our average rates of change. So it's a function that tells us the instantaneous rate of change at any point in time. We come across two types of functions, and two types of problems frequently occur, and that is determine the rate of change at a certain point, or determine when a certain rate of change occurs. So in the first case, what they're asking us to do is determine the rate of change when x equals something. Now, if my function didn't have x's, it had m's or q's, it would be determine the rate of change when m or q equals something. What's the process? If I've got this as my question, what would be my process to the right? What's the first step? Before that? Before that? Yeah, actually do the f dash x, do the derivative. So f dash x equals 8x. Do I have to do anything else? Not yet. Now what do I do? Let x equal 2. So in that case, I had determined what the rate of change at 2 is. So when x equals 2, the rate of change is 16. Cool? Does that make sense? So in a speed context, if this was my distance, distance function, I've created my speed function, I've subbed my time in, my speed is equal to 16 metres per second. Happy with that? In the second example, this is like saying, well, tell me when the car reaches 6 metres per second. What do I do? First step? Find the derivative. Is that the same for both functions?
Yeah.
So regardless of whether I'm being asked to determine the rate of change or determine when the rate of change occurs, my first step must be to actually do the derivative. What's different this time? This is where it's different. I let 6 equal f dash x rather than letting x equal something here. So I've got 6 equals 8x. Now what's the process that I need to use? I need to rearrange, which I do by dividing by 8. I get x equals 3 on 4. Happy with that? The world's worth looking for. So with most of these derivative functions, they're going to ask us to do one of those two things. And it's really about first steps deriving and then identify what does it need from there. Is it asking me for the rate of change, or is it asking me for what is the rate of change at a certain x point? So what's the real trick? Is it looking for the x value, or is it looking for the? Which one of these do I need to find my x value? 2 or 1? Number 2, correct? So in this case, it's giving me a rate of change, and I need to find when that equals x. And in this case, what am I asked to do? Find the rate of change at a specific x value. Cool. We also need to be aware of a few key terms. What does initial mean? Starting. So what happens at initial? What does time equal at initial? Time equals 0. Does that make sense? What does constant mean?
Consistent.
Consistent. What does something that's consistent do? It doesn't. Starts with C. Doesn't stop, doesn't change, correct? Are we good with that? Are we happy with how most of these problems are going to come up from this point on? They're either going to ask you for a rate of change, or they're going to ask you to identify when a rate of change occurs. Are we all good with that? We're happy with that? That was one. We were pretty good with that when I saw it. What we're going to look at